All right, here is the quiz review video for the first derivative test. On page 15 for problem 1, first find the derivative using the power rule. 3 times 1/3 is 1. Reduce the power by 1, minus 2x minus 3. Set the derivative equal to 0. We're going to factor. What multiplies to -3, that adds to -2. Set each factor equal to 0 and solve for your critical values. So critical values are x equals -1 and 3. To set up the test on the table, we're going to do the -infinity to the first critical value in numerical order, then that critical value to the next one, and the last critical value to infinity. So you're really making a number line from -infinity to infinity with breaks at your critical values where the tangent line has a slope of 0. Now we're going to test numbers. You can either test mentally or you can test in your factored form. I'll use my calculator to show you how you do this in your calculator with the factored form. Pick a number, any number between -infinity and -1, and input that into your derivative. And the result of that is a positive number. Pick a number, any number between -1 and 3. 0 is the easiest. And the result is a negative number. Now pick a number, any number between 3 and infinity. Pick 7. That result is a positive. So that means the original graph had positive slopes on this interval, which is increasing. If the derivative is negative, the original graph is decreasing. Positive slopes increasing. When your function goes from increasing to decreasing, it would look like that, which is a maximum. So maximum when x is -1. When the function goes from decreasing to increasing, it looks like that, which is a minimum at the critical value of 3. We need to get these y values. Y values come from the original function. Derivative means slope. F of x means y. I think I'm going to type the function into y1 and use my table to get the y values. So I'm going to go second window, make sure independent is ask, clear out what's there, and I'm going to input -1 and 3. So the y value at -1 is 4.6 repeating, and the y value at 3 is -6. Increasing, I'm going to come to my table and use the intervals that I've already identified. Decreasing, use the interval already identified. All right, number 2. Find the derivative using the power rule. Set the derivative equal to 0. And to solve, we are going to factor out a greatest common factor of 4x squared, which leaves me with x minus 3. Set each factor equal to 0. X equals 3 is one critical value. And x equals 0 is the other. Set up your table, -infinity to the smaller x value of the critical values, 0 to 3, 3 to infinity. So you're taking your number line, -infinity to positive infinity, and having breaks at each critical value. All right, we're going to test numbers in the derivative. This time I think I'll just use my y equals again for my testing. So I put the derivative in y1, go to my table, clear out what's there. Any number from negative infinity to 0, any number between 0 and 3, and any number more than 3. And the signs we get are negative, negative, positive. Which means the graph was decreasing, decreasing, and then increasing. All right. Decreasing to decreasing is not a maximum or minimum. It's going to look like that. We only have a maximum or minimum when the positive negative changes at a critical value. So you can see in the first problem, we went positive to negative, that was a maximum. Then the signs changed again, negative to positive, created a minimum. Well, on the second one, negative to negative, that's not a sign change. So 0 is a critical value that is not a maximum or minimum. At 3, decreasing to increasing makes a minimum at 3. So there is no maximum. Now I need the y value. So I'll put the original function and that is a y value of negative 27. All right, increasing is 3 to infinity. Decreasing is negative infinity to 0 and 0 to 3.